Okay, the method that I'm going to demonstrate the implementation of is find min. And in the code, in the sample code, in this input and output.java file, you can scroll down until you get to find min. And this method receives an array of doubles. Okay, so just one double is a number with a decimal point. With the square brackets, okay, so the way a declaration works is that you have first the variable type and then the variable name. And the variable type is double, but with the square brackets, it means it's an array of doubles. It's holding more than one. It's holding a bunch of them. Okay, so when this method is called, it's passed an array of doubles. And so inside of this all doubles variable, there is an array of doubles. And the job of this method is to find the smallest one and return its value. So the idea of a for loop, and they're really useful when you have collections of things, either an array or an array list. We've seen some in array lists. We'll go through them in more detail later. But here we're going to go through arrays in detail. The idea of a for loop is to calculate something or do something on every element of the array, or maybe a selection of the elements in the array, whatever. In this case, it's going to be every element in the array. And you almost always have a certain thought process when you're doing this. There is something that's called a loop invariant, something that you set in such a way that it's true before you start. You maintain it as true as you walk through the array, and then you can make some big generalization afterwards about that thing. So find min, the loop invariant that I'm going to have is I like to think of it as the minimum so far. So I'm going to initialize some variable to be the smallest element I've seen so far. So, and it's going to be a double. It's going to hold the double. And I'm going to call it retval. Because it's going to be my return value. When I'm done, I'm going to return it. So I might as well say return retval right here. Now I've got to initialize that return value to something. Now I have to be a little bit careful. Some people will like to initialize it to 0. And in some of these methods, that'll be a good choice. But that doesn't necessarily work here. What I'd like to do is I want to just look first at the very first element in the array. Because under my preconditions, I can assume that the array contains at least one value. And the first index in array is always index 0. Okay, so I'm going to say retval is equal to all doubles sub 0. And the way we read this with the square brackets is sub. So what I'm doing is I'm indexing or finding a specific element in this group of elements. And this number, this integer that goes inside of the square brackets tells me which of the doubles that are in the array I'm indexing. So the 1.1 is stored in the first place, so it's at index 0. And the negative 2.5 is at index 1, the 3.7 is at index 2, the 0.2 is at index 3, and the 2.6 is at index 4. And so right now, if I have looked at that first element, retval is equal to the smallest one I've seen so far. Well, I've only seen one, so the one that I've seen is the smallest I've seen so far. Now, I would like to go through the rest of them. So I want to say something like 4. And then I'm going to initialize an index. I'm going to say int I is an index, and I'm going to say set it equal to 1. Now, this expression before that semicolon is done exactly once when I first start. It's called the initialization phase of a for loop. And then I less than all doubles dot length. Okay? So this second part, okay, that goes in between the two semicolons, this is a conditional expression. It evaluates to true or false, okay? And I'm going to put an open squiggly bracket and a close, and when I hit enter, Eclipse will add a closed squiggly bracket here. So if this condition is true, the computer will do the stuff between the squiggly brackets. So it's a lot like an if statement, but it's a little bit more powerful, right? Because if this is true, it'll do it, and then it'll come back around. So it doesn't do it just once. When it comes back around, it'll then do this third statement, and my third statement is going to be I++. I++ just adds 1 to I. So it's going to add 1 to I and then come back around and reevaluate this statement. Now what is doubles, all doubles.length? That's the length of the array. Essentially it tells me how many items are in the array. So in this little example here, there were 1, 2, 3, 4, 5 different numbers stored in the array. So its length is 5. So how many times is this going to go around? It's going to go around when I is 1, because 1 is less than 5. Then I becomes 2, and it comes around and it does 2 is less than 5, so it's going to go through again. I becomes 3, and then 3 is less than 5, so it goes around again. I becomes 4. 4 is less than 5, so it comes around again. And then I becomes 5. 5 is not less than 5. It's not less than the length of the array, so it exits without going through the loop when I is equal to 5. And that's really good because we want to look, we've already looked at element 0. Now we want to look at elements at index 1, elements at index 2, element at index 3, and element at index 4. And then we don't want to go through when it's equal to 5. And so we say as long as I is less than length. And so this is sometimes referred to as a walk through the array. We're going around and around and around the loop until we have visited each element in the array. Now it's really common to start I out at 0, but we've already handled the 0 element, so I'm going to start it out at 1. And so what do I want to do inside the loop? I want to maintain the constraint that my return value is equal to the smallest element I've seen so far. So right at this point, I'm looking at element 1. And I want to say if element 1 is smaller than all the ones that I saw before it, then my return value is going to be equal to the thing at element 1. So I'm going to say if all doubles sub I, okay, the element at the current index is less than my return value, which is the minimum that I'd seen so far, or the minimum before I looked at this one, then the new minimum is equal to all doubles sub I. Okay? And so now if I have maintained, this statement is enough to maintain my constraint that red val is equal to the minimum I've seen so far. So if I go on around and around and around, looking at individual elements, and I've looked at every element and I've maintained that constraint, so I can say, all right, if this is equal to the smallest I've seen so far, and I've looked at all of them, it must be the smallest of all of them, so I can return it as the minimum of the entire array. This function is done. In the next video, I'll show you how to test your code.